Hey folks, Mark Brown for Azure Cosmos DB Live TV. Welcome. This week I got with me Govind. How are you, sir?
Good. How are you, Mark?
I'm doing fine. Enjoying the smoke-free weather here in Los Angeles. Unlike my friends over in the East Coast of the U.S. who are probably wearing masks right now,
Yep.
it's nice for the first time in a long time that I'm not swimming in forest fire smoke. Although I don't consider myself lucky. I consider them unlucky through that. But we're not here to talk about that. We're here to talk about some pretty amazing stuff you've been working on. Let me have you introduce yourself first, and then let's get into it.
Sure. Hi, folks. My name is Govind. I work in our global black belt team, focusing on app innovation areas. And specifically, what that means now is developing intelligent apps with our AI orchestrators.
Yeah, so I met you, just a little history, by total accident. You have a similar first and last name to a guy on my team, and he got accidentally forwarded an email that had a link to a GitHub repo that was Project Miyagi. And I took a look at it and I said, oh my, this is amazing. I've got to meet you. And so I reached out and we had a conversation and we talked about Project Miyagi. We talked about, was it Red Dog? What was the other one?
Yeah, Red
Yeah,
Dog.
Red Dog. And I was blown away by that. And then I showed you some of the stuff I was working on. And you're like, wow, okay, cool. Let's party on. So that's what we're going to do here today is talk about Project Miyagi, but just
Oops.
not
Sorry.
just that, but all of the other kind of technologies and everything kind of surrounding what you've built here.
Yeah, absolutely. So there's a lot to cover, and what we're going to do is just go through some slides for a little bit, and then look at the demo of Miyagi. That, as Mark mentioned, hopefully it's cool, and then we'll kind of dive deep into the underlying code as well. But before I get started, like let's just set the stage here. I think it's fair to say that we are going through the biggest technological shift in the history of humanity. We see this like I personally, and as a developer, I mean, Mark, I'm sure you as well with
Yeah.
Copilot, like one of our favorite key is to hit the tab key, because the answers are all there, and it's really the questions that we ask and how we ask them that seem to matter now. And we see this where every industry is kind of reorienting it, right? Google CEO kind of mentioned how this is more profound than humans discovering fire and electricity. So let's kind of take a step back and kind of walk through what happened, in the last decade, that all these breakthroughs that kind of converged and led to this moment. It really started in 2012 with AlexNet kind of taking on this ImageNet challenge and showcasing the power of deep learning and what these large deep neural nets when trained, in this case it was millions of labeled data sets and model sizes that were in the millions of parameters, and from that point onwards we are essentially writing on a bunch of exponentials, and we are now at billions of model parameters with trillions of unlabeled uh, data sets. And this paradigm shift, led Stanford to coin this term called foundation model. It is essentially after BERT, GPT, all these things. They coined this term foundation model, and what it is I'm actually quoting how they put it. While deep learning and transfer learning might have made it happen, it's really scale that made it powerful. And there were really three sort of main things that led to this. It's really the GPU throughput and memory capacity have been on a parabolic rise, and NVIDIA rightfully, gets a lot of credit there. But in addition to that, there has been some architectural leaps, such as the transformers architecture with its attention mechanism that allowed parallelizable training on these large data sets. Even software stack like PyTorch and TensorFlow with automatic differentiation, all those things made it happen. But the third one really is the internet scale data sets that we have. And with all that, they trained these models at such large scales with large data sets to predict the next token. Turns out that prediction task allowed it to really be the sort of multitask model that allows you to, do a bunch of these machine learning tasks. Traditionally, I don't know if your viewers have seen like this Silicon Valley TV show. There's this character named Jin Yang who builds this hot dog, not hot dog app. And
I've never seen that show, by the way. I
okay.
know that's probably I'm probably now going to be an outcast in my own show, but I've never seen it. Sorry, if it's not
well,
like on ESPN or like it's like Sesame Street.
yeah, it's on HBO. You should definitely catch it.
Okay.
It was on HBO, not anymore, unfortunately. But one of the things that he does there is he builds this not hot dog model, right? So it's one narrow model with sort of labeled data set, and it only does one thing. It identifies if a picture has a hot dog or it doesn't have a hot dog. But now with these foundation models, it's like this one size fits all model that can be adapted to do many tasks like code generation, sentiment analysis, classification, and things like that. In fact, the crown jewel manifestation of these models is none other than ChatGPT, the fastest adopted technology in the history of humanity. Right, 100 million users in 2 months. In fact, that wouldn't have been possible without Microsoft and specifically Azure, where the Azure substrate was used for the training and serving. And in fact, Mark, you told me that Cosmos DB is what powers the ChatGPT history.
That is correct. And as you can imagine, their growth has been, meant a lot of growth for us as well. Just the number of requests and chats in there. So Satya announced this. Well, I think it was during an earnings call a month or two ago, and then Scott repeated this at Build a couple of weeks ago. But yeah, Cosmos DB is storing all the chat history for ChatGPT right there in Cosmos. So pretty exciting.
Awesome. Yeah, that's very exciting.
And they picked us because we're primarily because of our architecture, right? We're scale out and we're elastic, right? And that's what they needed. Is they just did not need. They needed to go from gigabytes to petabytes and not have to care about that. And that's exactly what we gave them. It doesn't matter how big you get. You don't have to manage. You don't do anything. You just keep writing data. So yeah, so they're happy, and we're happy too.
Yep, that's awesome. Now, just kind of taking a step back again, the first principles of like the objective function of these large language models really is to predict the next word or token, and it might seem like a trivial task, but turns out that predicting the next word is actually means compressing information and knowledge, and the scale with which it was done led, in fact, there's a paper by Microsoft Research that kind of documents the in cognitive skills and capabilities that we deem as intelligence, how well it performs on par with humans in several sort of domains, and in some domains it even exceeds us, right? And we see this when we use especially the GPT-4 model, when we round trip with it. So there's a lot of value in embedding this intelligence into our customer touch points, in apps and things like that. So at Build, we introduced this copilot stack from Microsoft, and there's a lot here, but it all started with our sort of state-of-the-art AI infrastructure that really allowed OpenAI to train these large models, and of course serve as well. And then we introduced some announcements. We made some announcements in the how you can essentially fine-tune some of these foundation models. We'll get to this in a bit, but one of the key areas that I'm like super excited about as a developer is the top and the middle area. Sorry, I'm still getting better with Zoom it. So it's starting with how our customer touch points are going to evolve, how we're going to infuse AI, and how in the back end we're going to orchestrate these round trips with the large language model. And let's kind of zoom in on that orchestration layer. There are a lot of opinions out there. There's a lot of open source SDKs out there, and one SDK from Microsoft that is powering some of our copilots announcements, which you have seen, I'm sure, is called Semantic Kernel. And there's a talk at Build by the Semantic Kernel team. You should definitely check it out, and they go much deeper. Here, I just want to surface up, what it is. So it is basically an SDK that you can add as a dependency to your app. Right now, it supports C#, .NET, and Python, Java, and TypeScript are coming soon. And what that allows you to do is easily bolt on AI, to your apps. So, and I know in our initial thing we talked about a RAG pattern. So we'll show you how you can achieve, these sort of complex orchestrate these new design patterns that are emerging, with semantic kernel, and the extensibility of semantic kernel and the network effects that it has, allows you to, easily integrate with existing states. Azure Cognitive Search is one, but Cosmos DB, Postgres, SQL, PG Vector. And there are other vector databases from Microsoft, Redis, etc. You can add state as well as introduce side effects to your app, and we'll dive deep. And now,
So
of course,
can I ask you?
yeah,
I want to just pause for a second. So,
absolutely,
and just for people that are new to this space, I think most people now understand. You've got this notion of a prompt, like a question you may ask, and then a completion or a response from a large language model, and then also kind of within that context, you have what are user prompts, you asking the question. There's also what's called system prompts, right, where you're providing additional context about how the agent or how the model should behave, right? And I've seen examples of this where they're saying, hey, you should be friendly or snarky. Only answer the question if you know the answer. No bad language, no other stuff. So it basically defines the behavior. And then we'll talk about RAG pattern, where I've seen also you can use system prompts to give it more knowledge than it may have. But explain what semantic kernel does in the context of that. Like, why would I use it? What are the benefits of using something like semantic kernel versus just, I don't know, writing some text and plugging it into my completion API?
Yeah. No, that's a great question, right? So you can absolutely do that, which is you can have your prompts, be in your code, and then you can then, make the API calls. Because at the end of the day, semantic kernel is also making the same API call to the OpenAI models. Now, however, to do that repeatedly and reliably, right? And in addition to introducing, like augmenting the prompt, you're gonna be orchestrating these flows on your own, right? You're gonna, for example, um, with state, there's this new thing called vector stores that are emerging, and we can talk more deeply into that. You might add, you're going to have to orchestrate this flow where you, at the runtime, when it's round tripping to the large language model on that forward path, you're going to make those calls, aggregate the data, and enrich the data that is going to the LLM, because the large language model, you want to ground it to your domain, right, or to the context. And the way you ground it is you exploit the capability that it has called in-context learning. So you have to augment the prompt. And as you said, you have your system message. This is for the chat completion type of thing, where you force it to, act as a certain way. There are also knobs like temperature, things like that. So semantic kernel makes it easy for traditional sort of developers. I think we're all AI app devs, as SK team likes to call us, to add a dependency, and without worrying about the models, and also the models itself. Like right now, you have the OpenAI models, but there's also other models that you might want to orchestrate with. So,
So
yeah,
is it like a configuration framework then for interacting with these models, these different models, foundational models that OpenAI has? Is that because I know some of the answers to this, but I'm trying to get you
yeah,
to
absolutely,
kind
absolutely.
of feed the audience here on
No, no, no,
how these things work.
Yeah, no, that's a good question. So there are like tools right now with LangChain, Llama Index, and things like that, right? So this plays in that same space where it tries to, again, actually in the next slide we'll kind of see that, right? Where it serves that purpose of flow with how you orchestrate with these foundation models, and like again, it's a trade-off where you use what framework, but essentially it is about allowing you to add a dependency to your app and being able to invoke these models and achieve these new sort of design patterns that are emerging, for example the RAG pattern, or even like so some of the prompt engineering stuff. And when we get to actually this Miyagi sample, I'll show you how we are using connectors that's with semantic kernel and introduce extensibility in the runtime of execution. I know I said a lot, but hopefully the subsequent slides will cover some of the
No, I
aspects.
think that I think it's fine. There's a lot of information that people are trying to, I think, absorb around this, and some of it is just I know people are confused. Like, what is it in the first place? Why would I use it? Benefits, that sort of thing, and then it's all this orchestration bits like flow. I saw this demo at Build. Seth was doing this build during Scott's keynote. And that was pretty mind blowing. I also watched the breakout on this as well with the Azure ML team, where they kind of went a little deeper on it. And this is really cool sets of technologies that kind of hang off this core of these foundational LLMs that we've got, and helping you interact and program against them and refine. Because, like, at the end of the day, these things are not deterministic. I had to explain this in a lab I gave at Build, but or even in a demo. I did a demo and I asked a question and it gave me a really unexpected response. And I'm like, oh, I'm glad it did that, because let me explain to you something. You could ask the same question twice and it may give you two different answers. And so that's I think we're kind of the genesis of where things like prompt engineering come from, and how you construct these things and how you instruct the model to behave and how to answer and the information it gets, all that stuff.
And also how you dynamically populate the prompt, right? So imagine your prompt having variables that personalize, for that user's context.
Yep.
So with these orchestrators, you can essentially, achieve that. It's like a string replace on steroids, let's say. Now, again, what we're talking about is, more than just a chatbot, right? We're talking about assistants that boost productivity, right? So with this Miyagi sample, one of the things we're trying to highlight is how you can, create these hyper personalized experiences for your users. So, yes, there's a chatbot, but in addition to that, you can have the model synthesize information about the user's preferences and your proprietary data sets and present, insights in their end user experiences, whether it's a UI or some other way. And this is a sort of slide from Andreessen Horowitz, and it kind of highlights that this is going to be the decade of generative AI, right? In every modality, you're going to see, things generated, whether it's generating the next text or pixel or video frame, it's going to explode. But at the same time, there's a lot of value in synthesizing all that information and surfacing up as insights to your users. So it's hopefully what we're trying to highlight with some of the use cases that we're trying to tackle there. Now, this is a slide that hopefully will answer some of the questions you were asking earlier. So what I'm trying to show here is the different phases that you can kind of take to achieve domain specificity, and also highlight some of the trade-offs that you might have to make to get more task accuracy. So on the x-axis, you have, more to the right is more complex. It's going to be a little bit more costly, and you might need more training data. On the vertical axis, I have sort of domain specificity and how you can improve task accuracy. So most of the time we're going to spend here, right? We're going to exploit the in-context learning capability that these models have, and do a lot of prompt engineering. We all will start certainly when I use ChatGPT, I'm talking, and we're even referring to it as it, right? So we're gonna, even though it's really just generating some draft or wisdom of crowds like response, it's pretty good. And zero-shot prompting is basically that, right? Just asking it a question and having it respond back. Sometimes, that may not be enough. We might need to do this sort of few-shot prompts or give it some examples, and have it be something like, as a SQL developer, write this query for me or something. So it kind of grounds the model and forces it to interpolate in that space. The other thing that's really taking off is this thing called chain of thought prompting. And this has a lot of potential here. In fact, OpenAI just released this week a research sort of breakthrough, if you will, where they were able to improve math accuracy by adjusting their reward model to reward how it is deducing rather than the outcome. So the gist of that is, if you want to improve model accuracy, there are a few ways. Have it kind of explain itself. Give some examples of like how you might do sort of chain of thought reasoning, and I have a link there that kind of expands more. Um, so I think this is a good strategy to invest in. The other thing, of course, we're seeing is with the retrieval augmented generation pattern, where you augment the prompt with all the authoritative data sets, that is going to ground the model. And then the another pattern is this reason and acting pattern, where in addition to using authoritative data sets and have it reason there, you can also augment it with some affordances or tools. And of course, the way I think most app devs are going to, introduce intelligence, if you will, to their backend is by bolting on these orchestrators like Semantic Kernel, prompt flow, etc.
Yeah, I'm doing rag pattern right now. I have I have 2 sample projects I've created, the ChatGPT one, and then I've got a new one that's basically doing the vector search with the rag pattern there. And my prototype for this thing was just, it was very simple. It was just basically a vector search, grab a bunch of data out of a database, jam it into a prompt, and have the user ask a question, or user ask a question, vectorize that, search, grab all the data, jam it in completion in a prompt, and then have it spit back an answer in there. And I'm getting that work is all getting kind of like polished now, and they're going to implement, the people working with me are going to implement Semantic Kernel on there, so they can be just properly done, right? Like I did it in kind of a brute force kind of dumb way, but when I'm got like just a few weeks to make something work, I didn't have the time to kind of go into the Semantic Kernel. And then the prompt flow, I can't wait for that to become more broadly available, because I'm absolutely blown away by what you can do there. And the chain of thought stuff, I think that's fascinating. It's almost like telling a kid, "Hey, show me your work," if they're doing algebra, right? So
Yes.
if you're telling that to a model,
Yeah.
like, "Excuse me, can you show your work in there?"
Yeah.
And
Yeah.
it's
Like really,
fascinating.
force it to justify and cite its sources. Like it improves incredibly. Yeah,
Yeah.
absolutely. And then this is just an area that certainly don't get started here. But if you do have the need for more task accuracy that you cannot achieve with general prompt engineering, you may look into fine tuning models. And in fact, a lot of the open source community, I know Databricks is suggesting go this route. And again, here Azure and Azure ML have a lot of capabilities, and I'll showcase some of this, right, where you can sort of fine tune some of the Databricks' Dolly model and things like that. You can even fine tune OpenAI based models, right? So what this allows you to do is really ground the model to your domain specific data sets. In fact, Microsoft is a thought leader here. A lot of the ways you achieve fine tuning is by using like our optimization stack, like deep speed and low rank adaptation for parameter efficient fine tuning. A lot of these things have been open sourced by our MSR colleagues, who are absolutely geniuses in the space. And then the sort of third area is pre-training your own model. This is I would definitely avoid it. I think the only instance I've seen this by by like a traditional company is Bloomberg. They built Bloomberg GPT. In their case, they had large volumes of data sets and they wanted like a proprietary LLM. And yeah, we're not going to explore that for sure. So there's a lot that was said, but I think we just got to take a step back and remind ourselves what Steve Jobs left us with, which is start with the customer experience and work backwards to the technology. Right? There's a lot that's going on right now, and almost every day wake up and there's something new to learn. But focus on those customer needs that you're serving, and that's why in this workshop, we start with the design thinking session. So I think you might have pasted the link in the show description, but
Put it up
basically,
there for you.
cool, awesome. So what we're trying to highlight is, so we start with the design thinking session so that it is relevant, and hopefully the things that you learn here will serve your end user needs and alleviate their pain points, right, with this new technologies. And what we're trying to show is, you might have your traditional sort of apps and how you can bolt on AI with these purple boxes here, right? That's the sort of gist. And how new user interaction patterns are emerging. For example, I'll show you a demo of ChatGPT plugin, right? How you can securely host it behind, in our Azure sort of primitives, and how you can kind of, ensure that it is securely accessed by, oops, I'm trying to draw an arrow with with the zoom it's kind of hard, right? So how you access securely, right, from AI.com or Bing.com. By the way, you know that AI.com redirects you to ChatGPT, right?
Oh, it does. Well,
Yep.
that's cool.
Yeah, they actually paid a lot of money for that domain name.
Yeah, I wonder.
Something's coming.
Wonder who's been squatting on that domain for 2 decades.
Exactly. Yeah, that guy made a lot. So there's also more samples. I think, Mark, you called that this Red Dog. This has actually been developed by the America's Global Black Belt team like 3 years ago, and I just have like the Java version of it with OpenAI. So what I'll do now is I'll kind of show some demos, and then I will hopefully they'll open up the art of the possible, and then I'll walk through the code, and then we'll go back to the slides and conclude. So this is like a typical, event-driven, cloud-native event-driven architecture, right? Where you have sort of events flowing, and you have some orders being made. And what we're trying to show is even with this sort of brownfield type of app, how you can bolt on AI. So it's a simple example, but it shows the power of generative AI. So here, you might have it is not in the critical path, right? So if you just want to get started, go to OpenAI, spin up a new service, and start invoking with the API. So this is one example where you might want to personalize the product description or the product tags, for a user. So you can kind of see how we generate product tags, based on some product description. Now it can generate text, but it can also generate pixels, right? So here's an example, and we have Azure Hugging Face inference endpoints. So you can kind of see how you might have your proprietary data sets, and you can use that. This is a diffusion model as opposed to a language model, and you can use that to generate new images. This could be like a personalized medicine type of scenario where you might want a pill that is personalized to a user or something like that, right? Again, the use cases are closer to those serving the user needs, so your use cases more, but we're just trying to show some of the possibilities here.
Do you have a link for that GitHub repo I can put up for our users?
Yeah, absolutely. Yeah. So it's under Azure, Red Dog Solutions.
So github.com/Azure/red dog. Oh, Red Dog
Solutions.
Solutions.
Yep.
All right. Here, I'll show this up for users so they can grab it.
Cool. Awesome. Thank you. And let's see. Yeah, there we go. So the model loaded, it generated some images based on this data set. And this is just a simple sort of example, right? You can also generate pills like that. Inference time can be slow because this model is not exactly optimized, but there we go, right? You've all seen this, I'm sure, with Stable Diffusion and things like that. Now, let's go to Miyagi, right? So this is another art of the possible envisioning type sample that uses semantic kernel and highlights this, RAG pattern, right? So let me first show the architecture sort of diagram that we have here. Let me try to, oh, sorry. Okay, so what you're about to see is this flow, right? So we're gonna first have a prompt. Prompt is more complex than this, but what we're trying to highlight is how you're going to, achieve retrieval augmented generation. How you're going to, go to the vector store, get embeddings that are pertinent to the ask, augment the prompt, have these things called connectors and plugins that allow you to further augment and populate the prompt dynamically with user data, and then go to the model. Another visual I have of that is right here, right? So let me go ahead and show that in action. So if you pay attention to, let me zoom in, you can see. So if you pay attention to these recommendations, like whether users should buy, sell, hold stock, etc., and how they should allocate their portfolio. So there's just an app that highlights, like a Mint or Robinhood type of app. So you have some stocks, etc., and how you should allocate that. So I'm gonna hit personalize, and here I needed to highlight domain proprietary data sets. So I'm just scraping some subreddits. So you So you pick like your favorite subreddit, you pick your favorite financial advisor, Jim Cramer, Susie Orman, etc. Uh, I'll just go with Susie Orman. And then you might, state your risk tolerance. Of course, all of this in a real world, you might already have these preferences about your user. I'm just demonstrating. So when I hit that button, personalize, what's happening is Semantic Kernel is orchestrating this flow, right? And that is what this diagram is showing. So it's first kind of taking that question, getting the basically getting the embedding for that question, the vectorized version of that question to do a search on a vector store. So this is where you could use like Cosmos DB's, Postgres SQL PG vector from the Citus extension, and then you can or Azure Cognitive Search, and then you want to populate some variables. You do that, and then you go to the completion endpoint, and then you get a response. And you force the response to be in JSON format in a certain way, and I'll show all that code. But as you can see, it got some cool response, right? And I tweaked the temperature setting to high so it can be more creative and funny. Uh, so this is in the voice of Susie Orman. I'll just do it again in a different
Well, you
voice.
want funny, you should use Jim Cramer.
Oh yeah, let's do it, Jim Cramer. Okay. That's right.
Like you should have him show up with a baseball bat or something like that when you pick him on your drop down.
But yeah, there's also inverse Jim Cramer index right now going on. Okay, there we go. So this is how Jim Cramer might say about Microsoft, right? Go all in on tech stock, safe bet, blah blah blah. I'm surprised there's no booyah. Sometimes I see booyah responses and things like that.
There you go.
Let's see now.
Yeah.
And then there are other use cases too, like you could do. For example, you might want to do a classification task. Typically you might need a narrow machine learning model for this, but now you don't, right? You can just have expenses be classified into some categories, right? And I'll show an example of that. And then you could probably recommend expenses. And of course, there's chat on the side. So chat history is in Cosmos DB, just like ChatGPT, as we noted earlier. And you can kind of look at your chat history and you can converse with it, right? You can ask, what is a K or some natural, and I'm trying to build more capabilities for the chatbot so that it can do intelligent things like actually call an endpoint.
So is that are you using like classifications type of prompting in there to do that on the expenses? Explain to me what you're
doing. Yeah, sure. Actually, I can show that with prompt flow.
Yep.
We're kind of jumping ahead.
Oh, good. All right. Or I'm either helping you segue to something or I'm cutting. Or
no. It's totally good. This is ad hoc. So so just want to highlight prompt flow. Right? It's a very easy example, as you can see. So all I have is so for those that may be new, so this is our version of a low code, no code way of building prompts. In the industry out there, there's things like LangFlow and things like that. But prompt flow, I think, is a little bit better because not only can you compose prompts, use Semantic Kernel here as an SDK if you'd like, but you can also, again, with all the answers being there, it's about the questions you ask. You can introduce some engineering rigor to your prompt or how you ask the questions. So you can have some variants. You can, do some bulk testing where if you want to, let's say, because you really want to measure, how good it is doing, right? Measurement is very important, and you can have it do that. Like you can have some prompts and some questions and answer data sets, and you can evaluate how grounded the response is for a certain prompt, right? And you can measure that. So it's really cool way to kind of compose prompts, and you can also host it if you'd like. So in this case, for the expense classification, all I'm doing is I have a prompt here. I actually have two variants. So the first variant is, so I'm trying to highlight the power of chain of thought reasoning. So in the first variant, I'm just saying, you're an expense classifier, respond back in valid JSON, classify and include a justification, etc. Right? And then here's the JSON, and I'm telling it to like populate only these two sort of entries, and then it does its thing, and then it kind of populates. Now, the other variant I have is I actually have an example here. So this is more like a few shot. So with an example, I'm kind of telling it, okay, so for Chipotle here, it's usually where people eat lunch, blah, 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 and things like that. And how its justification should be so that it knows, okay, that's how I should write my justification.
Oh, so this is a justification for eating at Chipotle?
No, it is a justification. Sure. Actually,
Scott Hanselman write that justification
exactly.
for you. Yeah.
Exactly. So this is just kind of like I guess what I'm trying to do with this example is how it should justify why it categorized a certain expense, a
Got
certain
it.
way, type of thing.
Got it. I love how
uh,
it's all parameterized in there. That's
yes.
very cool
Yeah.
versus
Yeah.
the way I
And
had done it with rag pattern. I was just dumping whole JSON in there, but this is it's more refined, right? What you're passing into it there. So yeah, this is just a much cleaner way of doing it.
absolutely. And the other cool thing is, on the round trip, I kind of highlighted this in this architectural flow, where on the forward path you augment, but on the return path there's also things that you can do, right? You can validate the model output, and maybe you need to retry, and semantic kernel actually allows you to do this easily. You can evaluate how deviated it is from the ground truth, right? You can um, you know I'll show our new UI sort of stack that's emerging, where you can ask users for feedback and use that to improve the model performance, or even like measure your prompts. So that also can be easily achieved here. So once you're kind of done with that output, you can take that output and kind of validate and parse it, so that it's consistent with what you expected. And yeah, there's a response. Right? It's very simple. But then the other cool thing, since you mentioned RAG, is you can do that with the tools that they have. So you can actually have a vector DB lookup introduced in the flow,
Yep.
to do content safety and things like that. Actually, check out Seth Suarez's demo at Build. He did quite a
Yep.
job here.
That's what I saw, and just
Yep.
my jaw dropped when I watched it. I'm like, wow, that's amazing.
Yeah, it's really cool. So yep. So there it is. It responded back, right? The chat one, because again, the chat bot is also kind of uh, not fine tuned, but it is grounded to the domain. And the other thing is, semantic search, right? So we are, I think after what Google did with BERT, we are now in this phase of doing enterprise search is going to evolve into semantics, and this is using. It's not developed yet, but all I'm trying to highlight is how you can search for meaning with our Azure ACS, Azure Cognitive Search.
Mhm.
Now, kind of just taking a step back here. So we saw a few things there, and then the other one that I just want to highlight is the use cases. So one of the things I'm trying to do with this Miyagi thing is show all the use cases, or at least, sorry, a subset of the use cases that we're trying to achieve here with code and prompts, and things like that, and connectors and all that, and how you can take this and use it to solve your own use cases, right? Whether it's synthesizing information, or building a conversational bot, summarization, classification, things like that. And then there's also, I think I just touched on it, which is how you can do like plugins. So I'll show that in a bit. Prompt flow, and then how you can, this is more advanced, but how you can kind of fine tune models and things like that, and how Azure ML makes that easy now. So let me jump to plugins. So this is kind of like the new app store, if you will. It's absolutely wild and exploding like crazy. So right now, if you go to the ChatGPT plugin store, and if you look at like all the new plugins that are coming up, it's really crazy, right? So this allows the model to essentially do RAG kind of on its own. So basically, it will um, like when a question is when it's not sure, or when a question has certain sort of keywords, or semantics, it is going to make an invocation to these sort of plugins, and then get the response, and then ground its response to whatever it says. So like Bing actually has been doing this with the new Bing, right? It does a search.
Yep.
So similarly, you can develop your own plugin, right? So I have this Miyagi plugin that, like, if you like, without the plugin, if you ask what Miyagi is, it'll say like it's a movie character from Karate Kid. Actually, my colleague David Barkle, who
Yeah.
Mark, coined that because he was watching Karate Kid with his son, so that's why I came up with that.
Oh, is that where it came from?
That's where it came from. Yes. Yes.
Okay.
So if you see now, if I ask what is Miyagi, it should say, uh, there you go. In this context, it is a plugin or a tool to fetch financial information. And it even tells us that it is from a character from Karate Kid. So it's pretty cool, right? So and then once the plugin is there, you can then have it make API endpoint calls, and fetch a domain specific data and things like that.
I mean, you could, I guess, implement rag pattern there and put a little blurb in about how that name came in, so it uses that
Right.
instead of what it just used there.
That's right. That's right. Yeah,
Yeah.
should do that. Yeah. Um, and then the other thing is, yeah, so if you're okay, I can kind of go into the code and show like
Yep.
how we're trying to achieve that. Okay,
People here love code.
great. So this is part of that flow that you just saw in Miyagi, right? So this is in C#. Again, you can do this in Python. I usually prefer sort of dark theme, but Mark kind of told me to lighten the theme here.
Yeah, don't use dark theme. Sorry.
No worries. So here, what we're trying to show is first, this is how you kind of, initialize the kernel, and you kind of configure it with your text completion model, your embedding model, and things like that. And then from there, you can add your memory stores. In this case, I'm just using like volatile memory, but this is where you can use like PG Vector from Cosmos DB's Postgres, Azure Cognitive Search, or Redis. And the vector indexes it's like a competitive market there, with which one has a better vector index. So anyway, that's another topic for another day. And as you can see, when you configure, you can also have it make the response more reliable by introducing exponential backoff and retry and things like that, and it makes it configurable. Now, if you were to do it without the kernel, you're going to have to add the retry logic and all that stuff, and
Those
make
get
those.
plugged into the OpenAI client. Is that what that's for?
Yeah. So the kernel, which is the dependency, has those packaged in it.
Got it.
Yep.
Okay.
So all you have to do is pretty much this, right? You don't
Well,
need
just
to. Yeah,
basically plug it into the semantic kernel config, and then it's gonna plumb the underlying OpenAI client.
that's right.
Got
Yeah.
it. Okay.
And now once you have the kernel ready, yeah, when you hit the when you hit that endpoint, the personalized endpoint where you saw how, like we showed with Jim Cramer, how he might allocate his portfolio type of thing. So here, what we have is that retrieval augmented pattern in action, right? Or generation in action. So here, first let me go to the prompt, right? And those are called skills, but they're just renaming that to plugins. And this is where you define your prompts, right? It's a simple sort of text file. So these are called sort of semantic functions, and all it is you you pretty much have some placeholders for that gets populated at the runtime. In fact, some placeholders can be like native functions. So, for example, in this case here, I'm actually, or in this case, what's happening here is I have a custom, function that is going to get this variable populated dynamically, and this function will execute. It will wait for that response, and then it will augment the prompt. So you see all this stuff. For example, let's say you need to look up user info from LDAP, right, at runtime. This is highlighting how you can do that, right? So you can, I have some, fake data here, right? So I'm just showcasing how you can get user's age, for example, given like a user ID or something like that, and how semantic kernel will orchestrate that flow simply by adding this to your prompt, and this function you probably already have, things like that. So let me
Oh,
go.
this is kind of cool. So
Yeah.
you can use this to basically bind it to basically a public function or a function that's in scope.
Yeah.
For
Any.
what
Yeah. It's like
anything.
the extensibility is really cool because really any endpoint, any endpoint, any method type of thing. Yeah.
That's pretty fascinating. Yeah.
And how that gets populated is basically you have to load like that function that you defined, and then you essentially set the context here. So all those variables are sort of set here dynamically, and then you can kind of tweak some of the knobs. I'm just outputting the number of tokens that I'm taking for this prompt because that is the cost. It doesn't matter how many times you round trip; it's really the number of tokens that you're using.
Yep.
And then I'm calling this Prometheus, but it's really so Prometheus is the model for Bing search and how it does it. But this is highlighting the Bing connector that is native to semantic kernel and how I'm just augmenting the prompt with the current inflation and the interest rate. So it does a search on Bing, and then it augments the prompt with that result. And then this is actually where it invokes all of that chain, like pipe, like in like a Unix type filter, if you will, Unix type piping. And yeah, that's basically kind of how it does it. And the other thing is, I have more code, but
no, this is fascinating. I think
yeah.
people should get in here. I mean,
Yep.
we could do probably 4 or 5 shows.
Yeah.
The things you can do with Semantic Kernel,
Yep.
and I'm still learning the stuff you can do, and it's to tell you, it's fascinating stuff. My brain kind of hurts if I spend too much time focusing on it one time, so I have to take a break.
One thing,
go ahead.
I just want to shout out to the Semantic Kernel VS Code extension, which allows you to easily get started. And then I have more slides, but I think we're at time. So
no, this is great. I actually saw that the other day. I bumped into their blog post for announcing the tools that I somehow had missed. I think that was back in April or whatever they had announced the VS Code tools. Anyway, and I went through their little sample. They're very, very easy to set up. Well done in there, and just will help people get started. I put up a link for their GitHub repo. More links to stuff in there as well. There's also, you can just Google this with Bing, but there's a whole ton of docs over on MS Learn for getting started with Semantic Kernel as well. And there's quick starts, samples, all that stuff. And of course, there's support for C#, which is great if you're a C# developer, Python, and the Java. When's the Java coming?
Yeah, so the Java one, there's actually a Java branch. You can go and get started with it.
Okay.
I think soon is all I'll say. There's also a TypeScript version that's coming out. And also, I think we talked about it for your audience. If you're using Cosmos, Postgres, there's also a Semantic Kernel connector that just got checked in a week ago. So there's an example of that as well.
Oh, very cool. Is there, someone asked me this the other day. They're like, is there a lot of stuff for Java in the OpenAI space? And it doesn't feel like there is, but you would know better than me because I know you did a bunch of stuff in Java. So.
Yeah, actually, the funny thing is, I actually made a core contribution to the Semantic Kernel team with the Java sample. So what I introduced was gRPC skills. So you can, if you have like a native Java connector, you can do this. Yeah, to your point, there isn't a whole lot, but again, if you go to the Java branch here, you can kind of see the kernel in Java, and it's evolving fast. You see, almost every day, right? So hopefully soon they'll have it ready for the Java devs out there.
Yeah. Do you know if OpenAI folks are working on Maven package for their like a convenience layer for their REST API or no?
Yeah, I'm not aware of it.
Yeah. All right. Yeah. Just curious. Yeah. Okay. Well, hey, it's an open source world. Like you can take anything that's basically exposed as a REST endpoint and and wrap it in whatever you want and ship it as a Maven package and off you go, right? So
absolutely.
Yeah. Well, this is cool. That's it, right?
Yep, that's pretty much it.
This is a great show. Thanks so much for coming. Very timely with all of the announcements we had at Build last week. I've been neck deep in working with this stuff since January. Like I obviously the announcement came out in November about the preview of Azure OpenAI out there and ChatGPT availability. And I spent all Christmas break mulling around this and came back in January and I'm like, all right, we got a bunch of work I got to do. So I started playing around with it and cranking out samples and just trying to learn as much as I can. It was all new to me. I mean, I'd never done any of this stuff prior to 6 months ago. I wasn't doing any of this. And now I've got samples up. I'm building more. I'm augmenting the ones I've got to add in things like Semantic Kernel. I'm looking forward to things like prompt flow, which I think is just fascinating. I mean, the kind of the tooling and the ecosystem that's building around this space is fascinating because they're really hitting a lot of the kind of the rougher patches there, and trying to make it easier for people to kind of, you know, increase the velocity, build the stuff they need to build, and do all of these things, whether it's, you know, improving their model, or not improving the models, but improving the performance and the way their applications are working, and going and taking applications and making them, you know, these intelligent apps. I see it with customers all the time, and I know as a GBB, I know you're talking to a lot of these same customers. I see it from other GBBs as well. Is customers are like, hey, show me what I can do.
Yeah.
Right. How do I take advantage? How do I get started on this? How do I use it? And you know, stuff like what you've built here is fantastic. I'm going to put up your intelligent app workshop, just intelligentapp.dev.
Yep.
You can go and download that and run it. I'm guessing people could just go and just clone this thing and
Yeah,
get
it's
to work,
not
right?
very stable, but yes.
Oh, well.
But I'm trying to document it, and, you know, going at I've never seen this much pace. I think we both talked about it ever. It's insane. Yeah.
It is insane, but I love it. I mean, that's
Yeah.
why I got into this business in the first place. Is I love to learn and I love challenges, and nothing better than something groundbreaking like this to come along during your career to kind of kick you in the pants. So good stuff. Thanks, Govind, for joining us. It was great having you. We got to have you back on, I think, at some point, and just kind of catch up on all the stuff, because it's moving so fast. I mean, I'm sure in 6 months or even by the end of summer, things are going to look a whole lot different. So
I get to super intelligence. I
yeah,
think
that's right.
fast.
Yeah, well, you know, general AI or whatever they call it.
AGI. Yeah, that's the
Yeah,
goal of
AGI.
OpenAI.
Yeah.
AGI.
We'll see. Hey, I might have a new host for the show. We'll have a AGI hosting the show, and I can relax.
Yeah, it'll be positive.
right.
So, yeah.
Hey, folks, thanks for joining us this week. I hope you enjoyed the show. Hey, join us every month for our Cosmos DB virtual user group over on meetup.com. Just go ahead and hit the link here. Join us. And we've got a new meetup every month that Jay and our team puts together for you. I don't know what episode this is. We're into the 80s now. I've kind of lost count. But we've got lots of other episodes as well. Come check us out. You can actually watch our build roundup from last week. We talked a little bit about some of this with Mongo vCore offering vector search and Postgres and PG Vector and a whole bunch of other stuff in there as well. So come check that out. Lots of good stuff for you to see, and hope you enjoyed this week's episode. We'll see you all next time.
Awesome.
Bye, everyone.
Thanks, everyone. Bye.